Combinations. 3. More examples. We have studied permutations and combinations. Many problems may require both permutations and combinations. Here's example 1 in the book. A club with 120 members wishes to select a president, vice president, and a 5-member advisory committee that reports to the president and vice president. The process is to select a president and vice president, then a 5-member committee from the remaining 118 members. How many ways are there to select a president, vice president, and a 5-member advisory committee? So here is how we think about solving this equation, solving this problem. So there are 2 tasks here. One is to first select a president and vice president, and then a 5-member advisory committee. So, and then let's look at task 1, select a president and vice president. So this one, because we talk about a president and vice president, so the order is observed, and then we have 120 members. So this is a typical permutation problem. We have 120 people and we select 2. So that's a permutation problem. And then the second task is to select a 5-member committee. Now, the 5-member committee here, there's no order is observed. So we do not separate these 5 members what they serve. We just simply select 5. So order is not observed. And it's from 100 people. So this is a combination problem, 118 people, and we select 5. So now we have 2 tasks in sequence, and then first task we have this many ways to complete, and then second task we have this many ways to complete. So the total will be probability 120 out of 2 times combination 118, taking 5 at a time. So that will be the total. So you can punch calculator or break it down to do more calculation. So let's look at this. Permutation 120, that is 120 times 119. So that's permutation. And then combination of 118, and that will be 100. That equals permutation of 118 taken 5 at a time, and then divided by 5 factorial. So this will be 120 times 119, and then this is 118, 117, 116, 115, 114. So you have 5 numbers here, 1, 2, 3, 4, 5. They have 5 numbers, and then divided by 5 factorial. Now you can punch calculator. You could also use a graphing calculator to calculate permutation and combination directly. So I leave this one for you to complete. So this is one example. Example 2, a shipment of 12 microwave ovens contains 3 defective units. In how many ways can a vending company purchase 4 of these units and receive A, all good units, B, 2 good units, C, at least 2 good units? So to think about A, all good units, because we are told 3 are defective, so there are 9 good units. So then we look at the outcome, 9 good units taking 4 at a time, because we talk about selecting 4. So we talk about 9 good units taking 4 at a time, and here we do not care about the order. So this is a combination problem, have 9 objects taking 4 at a time. So, and then this calculation will be permutation of 9, 4 divided by 4 factorial. So that will be 9, 8, 7, 6. That's 4 numbers for permutation. And then 4 factorial is 1, 2, 3, 4. So cancel, 2 times 4 is 8, cancel with 8. And then 3 times 6 is 3 times, cancel with 6, you get 2. So then you have 9 times 7 times 2, that altogether should be 126. So in this case, there are 126 different ways to choose all 4 good units. And then B, 2 good units. So, and then for this one, 2 good units, because the company want to buy 4, so you have 4 spots, and then 2 need to be good. So now you talk about 9 good units, taking 2 at a time. So for these 2 spots together, there are this many choice you can do, different ways you can do. But then for these 2 will be the defective units. So we have 3 defective units, and then taking 2. Therefore, to fill out these 2 spots, you have a combination of 3, 2. You have this many defective, to choose. So you have 2 tasks. You have this many ways to get 2 units of good from good units, and then you have this many ways to get 2 defective units from 3. So total, by the fundamental principle of counting, you take a multiplication of this, and that will be the answer for B. So to calculate this one, it's not difficult again. So we talk about, and this one, it will be permutation of 9 taken 2 at a time divided by 2 factorial. This one is permutation of 3 taken 2 at a time divided by 2 factorial. So you have 9 times 8 for the permutation, and then 2 factorial is 1, 2. And then this one, you have 3, 2, and then permutation 2 factorial is 1, 2. So they cancel out this, and then cancel this with 4. So you have 36 here, and times 3. So you have 108 ways to get 2 good units. For C, at least 2 good units. So at least 2 good units that include 2 good units and 3 good units. Because they are all together 4 good units, so you also have possibilities to get all 4 good units. So to get at least 2, you have these 3 cases. So the first case we already did in part B, so we know the answer will be 108. And then for this case, 3 good units, then you talk about 4 spots. 3 are filled with good units. So you have 9 units taking 3 at a time. So you talk about combination 9 times 3. And then this spot will be filled with defective, and in fact you have 3 defective, so you have 3 ways here. So by the multiplication principle, and this will be combination of 9, 3 times 3. So then combination of 9, 3 is permutation of 9, 3 over 3 factorial. So that will be 9, 8, 7. 1, 2, 3 for 3 factorial times 3. So you cancel this one. You cancel 2 with 8, you get 4. So 9 times 4 times 7, and that gives you 252 ways. And then for all 4 good units, and you have only, you talk about 9 good units taking 4 at a time. So this is combination 9 good units taken 4 at a time. That gives you this many ways to get all 4 good units. So that you calculate, it should be 126. These 3 cases are separated. They are not a sequence of tasks to complete. Therefore, the fundamental principle of counting does not apply. In fact, the total number of ways to do is to add all these 3 cases together. So therefore, the final answer will be 108 for 2 good units, and then 252 for 3 good units, plus 126 for 4 good units. So when we add all these together, The answer is 486. So that's how we consider. These three examples give you three different considerations, and one is quite simple. It's just a combination, and then two, you have to use the fundamental principle of counting to get the total for a sequence of two tasks. But this one, you have three different separate cases, and then the total is we add this. In particular, this people need to be careful. The fundamental principle of counting does not apply because these three cases are separated. Let's look at another example. Example 3, 5 cards are selected from a standard deck of 52 cards. In how many ways can a full house be dealt? What we mean by a full house is, consists of three of one kind and then two of another. So like this one, if you have ace, 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 that's three of one kind, and then you have 5, 5, that's two of another kind. And then another example would be like, queen, 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 and then you can have another pair that like 10, 10, or you can choose any other pair like A is also good, so that would be another full house. So there's quite many full houses. So, and how many ways we can get a full house? So in other words, how many full houses? To consider this, again, you think about 5 spots, and then the first 3 spots must be one kind. So for example, you can take A, but for one kind, you could have like a diamond, and then you could have like a spade. You could have a club, or you could have a heart. So you can choose 3 out of 4 here. So to get this spot, you first, if you choose A, then you have combination 4 cards taking 3 at a time. But you also can choose like 2 diamond, 2 spade, 2 club, or 2 heart. You can choose 2. So therefore, there are 13 kinds here. You can pick 3. Therefore, the total number of ways by multiplication principle for these 3 spots, there will be, you take 3 from 4, then there are 13 kinds of multiplication. And then for this one, 2 spots here, and you can, now, once one kind is used, then you only have 12 kinds available for these 2 spots. So you choose 12 kinds. So then you have 12 choices for these 2 spots. But each kind, you have 4 cards, like 2. Then take 2. So you talk about combination of 4 cards taking 2 at a time. So then by multiplication principle, you have 12 times this many for these 2 spots. And then these are 2 tasks to complete in a sequence. Therefore, we apply the fundamental principle of counting. That total number will be C combination of 4 taking 3 at a time times 13, and then times 12 times combination of 4 taking 2 at a time. So this one, when you calculate, and the total will be 3,744. As for homework, please look at assignment number 38.